In this video, we are going to talk about problems in quiz 2. The first problem, so here we have a rational function again. We want to find the limit of this function as x tends to infinity. Why don't you rearrange that rational function in this way? So negative x squared plus 4 divided by x squared minus 1. So you can divide both numerator and denominator by x squared, then this term becomes minus 1, then 4 over x squared, and you divide the denominator function by x squared. Then when you divide this thing by x squared, this becomes 1, then this becomes 1 over x squared. Now we are taking the limit, so you know that when 1 over something, so 1 over x squared, as x tends to infinity, what happened to the denominator term? That getting bigger and bigger, so then the result, this quantity approaches 0, right? So this quantity approaches 0, this quantity approaches 0. So we left with minus 1 over 1, which is 1. Therefore the limit of this function as x tends to infinity is equal to 1. Next one, here you are given the function f. So this part is not equal to 0. This part, when x is equal to 0, function is defined as 1 here. So value at x equal to 0 is f of 0 is 1. Why don't you simplify this this one here? So here x is common, you can take it out when you simplify this. This function, this rational function is equal to 1x plus 1, which is a polynomial. So because why we can simplify that? 2x plus 1, because x is not equal to 0, that's why you can simplify this, right? So which of the following statements are true? F of 0 exists. So f is defined at this point. So f of 0 is equal to 1. It exists. So limit exists. Let's see. So here when you simplify this, you get this polynomial. This is a continuous one. So as x approaches 0, this function approaches 1. So from both sides, when you approach 0, from both sides, you can see that the functional value approaches 1. So this limit exists. That is true. The limit of the function as x tends to 0 is same with this. This one is 1. Is same with the functional value at 0. Therefore this function is continuous. This one also true. Therefore, so which of the following statements are true? All of them. All of them are true. Next one, again we have a rational function. Why don't you simplify this? Why don't you rearrange this? Yes, I divide both numerator and denominator by x squared. So when you divide the numerator by x squared, so this term becomes 5x, and this term becomes 27 divided by x squared. And I also divide the new denominator by x squared, which is 20 plus 10 divided by x plus 9 x squared. Now let's consider x approaches minus infinity. So we know that so this term, if you consider this term as your denominator becomes a very large number, this quantity is getting smaller and smaller, and as x tends to minus infinity, this quantity approaches 0, this quantity approaches 0, this one also approaches 0. This is a constant value, so we know that x goes to minus infinity, this term also goes to minus infinity. Therefore, these all terms goes to 0, 0, 0, 0, 0, 0, and we left with these two. So 5x over 20. So as x tends to minus infinity, this term goes to minus infinity, right? Let's look at this this rational function. So this is another function. So here 2 to the minus x divided by 2 to the x. Why don't you rearrange this term? I take this term to the denominator, then it becomes this minus becomes plus. So 1 over 2 to the x times this number. So when you simplify this, when you multiply these two, then you get 1 over 2 to the x plus x is 2 plus when you multiply these two quantities, so look at the so this is the base, and you have to add these exponents, right? So this becomes 2x, and your base is the same, base is 2, so 2 to the power 2x. So here as x tends to infinity, so your denominator becomes this denominator is getting larger and larger, goes to infinity, 1 over something very big, therefore so that means the quantity becomes very small. That's why the limit is of this function is equal to 0.